Trigonometric substitution, there are three different ways. Just to remember that what function you will substitute according to the function. If you have the function like square root a square minus u square, means if you have the constant number before and any function u is later and minus between them, so then you put u, like whatever the u function here. U means, for example, you have 4x square, so you can write it as 2x whole square. So here u
Yes.
is 2x. So whatever the function is here, you will put that u is equal to a sine theta. Similarly, if you have the function is like a square plus u square or u square plus a square, like if they are adding in under the square root, then we simply put u is equal to a tan theta. And after plugging these values, you have to simplify the questions by using trigonometric identities. And remember the trigonometric identities. And if u square is first, like a variable in start, and a is later on, constant is later on, u square minus a square, then it will be u is equal to a secant theta. And what are three trigonometric identities that we will use to simplify? Sine square x plus cos square x equal 1. So if you
Hmm.
have sine square or cos square, we can find the value using this one. The second one is 1 plus tan square x equal secant square x. And the third
Hmm.
one is 1 plus cot square x is equal to cosecant square x. So here is a question
Okay.
which we will solve by using trigonometric substitution. Which trigonometric substitution we can use for this question?
Let me
It's x
see.
square, and under the square root you have 16 minus x square. So 16 minus x square means you have the constant in the start minus the variable, right? So if the constant first and then minus with the constant, so which trigonometric substitution we will use?
This one will be. What is the first one, right?
So if you have a square constant first and then you have the variable u square, it means we use the trigonometric identity a is equal to u is equal to a sine theta. 16 is 4 square. So if you
Yes.
write in the form of a, it would be look like 4 x square, and it will be 4 square minus x square. Now we substitute the variable, take the variable and put it equal to a sine x, right? X equal 4 sine, instead of theta I use x, okay?
Okay.
No, sorry. I use theta because the question is already in the form of x. So we'll convert it in theta, okay? So x is equal to 4 sine theta. Now take the derivative. So dx is equal to 4 sine, derivative of sine is cos theta
Cos theta.
d theta. So it means in the place of dx, you plug 4 cos theta d theta, and in the place of x, we'll plug 4 sine theta.
Okay.
So substitute it here. Numerator is 4 only and dx as well. So dx it will be 4 cos theta d theta. So it will be also 4 cos theta d theta in the place of dx. And
Yes.
denominator is x square. So x is 4 sine theta square.
Okay.
And 4 square is 4 square minus 4 sine theta square. Now it's time to simplify. So numerator multiply, it becomes 16 cos theta d theta. This 16 comes outside of the integral sign, right? And
Okay.
denominator is sine square theta, and 4 square is 16, which comes
Yes.
outside. So sine square, and inside it will be 4 square minus 4 square sine square. So now it becomes this 16 and this 16 is cancelled out. You left it as cos theta d theta divided by this is sine square theta, and under the square root this is 4 square. So when it comes outside of the square root, it just become 4, and it left 1 minus sine square theta d theta. This 4 comes outside, 1 by 4. Numerator is just cos of theta d theta. Now how can we simplify the denominator things? This is sine square theta and here is 1 minus sine square. So what is 1 minus sine square theta? How can we write it? That's why we are
Mm,
substituting, so that the square root term will be removed after simplification. So under the square root you get 1 minus sine square theta. So 1 minus sine square theta,
1 minus sine equals to cos square, right?
because you have sine square theta plus cos square theta, that is 1, right? So if you take sine on the other side, it will be cos square theta,
Yes.
that will be equals to 1 minus sine square theta. So use this thing instead of 1 minus sine square theta, we'll put cos square theta, right? So it will be cos square theta in the place of 1 minus sine square and the square root. And now this square and square root will be cancelled out. And you have 1 by 4 cos theta d theta, and denominator is sine square theta, and it left only cos theta. This cos theta cancel out. You just left d theta above, and denominator is sine square theta. Now what we can do here?
Mm, अब क्या होगा ये 1 minus
You have 1 minus sine square. How can you find the integration of 1 minus sine square theta? So 1 over sine square will become cosecant square. So 1 by 4 as it is. And this would become cosecant square theta d theta. And what is the integration of cosecant square theta d theta?
yeah minus cot.
So integration of this will be minus cot and 1 by 4 as it is. And it becomes 1 by 4 minus cot theta d theta. Sorry, not d theta. If you integrate, so then minus 1 by 4 cot theta. This is the answer. But this is not a final answer. You got this answer in the form of theta, right? Now you need to plug cot theta at the end. Answer is actually in the form of theta, right? So we will convert into x again. That is actually called resubstitution. Okay. Now resubstitution is, for the resubstitution you should have the value of cot theta, right?
Hmm.
So how to use this cot theta? Like, we don't have the value of cot theta, is it? We have the value of sine theta when we were substituting. Look at this, x is equal to 4 sine theta. So as we know that cot is cos over sine, but we have only the value of sine theta while we were substituting, right? Sine theta,
Yes.
x is equal to 4 sine theta. So what will be sine theta? Using this, sine theta will be equals to 4 will come on the other side, it becomes x by 4, right? So we got the
Yeah.
value of sine. So as we know that cot is actually, let me write it below. As we know that cot theta is actually cos theta over sine theta. It means we need to find the value of cos theta and sine theta. But using the resubstitution, as we already plug that as x is equal to 4 sine theta, right? Then
Yeah.
sine theta is equals to x over 4. If you have sine value, you can find the cos value by using this sign, right? How can,
Hmm.
if, like, you know that cos and sine are related by trigonometric identity, right? So
Yes.
if you have the sine value, it means you can find the cos value by using trigonometric identity. So what is the cos value? Cos square is equal to what? 1 minus sine square, right?
Yes.
And if you need to find sine square, it will be 1 minus cos square, right? So
Yeah.
as we have the sine theta value, just plug it here, and we need to find the cos square theta value, right? So cos square theta 1 minus, what is sine square? It will be x square over 4 square, right? Now take the LCM. 4 square 16, it will be 16 minus x square over 16, right?
Yes.
And after that, here is cos square, but we need to find the cos value. So take the square root,
Can. Okay.
and it becomes cos theta equals 16 minus x square, and denominator
Square
16 becomes 4
4.
if we take out from the square root.
And that's
So this is the cos value, and we have the sine value. By using cos and sine, you can find cot, right? That's why
okay.
we find the cos value. So let's find the cot now, because we know that cot is this one, right? So using this cot, so then cot theta equals cos over sine. What is cos? It's 16 minus x square over 4 divided by, what is sine? X over 4. When you simplify this, 4 and 4 will be cancelled out, right? It becomes 16 minus x square over x. This is the value of cot theta. Why we find this value cot theta? Because we got the answer minus 1 by 4 cot theta, and we want to resubstitute. So for resubstitutions, in the place of cot theta, we'll write its value, which is in the form of x. Okay,
Okay.
so the integral sign, so put in equation 1. In equation 1, on the other side, it's actually the integral, right? So the answer is, you have minus 1 by 4. You can write I on the other side. I means the integral. Okay, so I, the
Okay.
integral, answer you got minus 1 by 4, 16 minus x square over x. This is done. So this is the whole procedure. First thing is, do the substitution. After substitution, solve the value and you will get the answer in the form of theta, of course, because when you substitute, you convert x into theta. After converting this, you do resubstitution, and for the resubstitution, you have to find the value of the term which you got in the answer. It can be cot theta, tan theta, sine theta, whatever. So you can plug its value by using the same substitution. So as the substitution was in the form of sine, and we want to find cot. So sine, so cot is actually cos over sine. So it means you
Mm,
have the sine, you can find cos by using trigonometric identity. And once you use a trigonometric identity and cos is given, then you plug cos and sine both to get the cot theta. Okay, and cot theta,
okay.
once you find the cot theta, plug it in the answer that you got. And on the other side, it was integral, right? Actually, we solve the integral, so I write I on the other side. I means the question integral. Okay, so integral is equal to minus 1 by 4, and cot theta becomes square root 16 minus x square over x. In this function, the variable is first and constant is later on, right? So it means we can substitute. If you have this type of form, square root of u square minus a square, then we substitute u equal a secant theta, right? So
Yes.
if we put u is equal to a secant theta, now you need to know what is u and what is a here. So if you rewrite this function, so a, what is a here?
A here is A होगा 5.
Yes, 5. So it becomes x square minus 5 square divided by x. Now do the substitution. X equals, this is substitution, because we do the resubstitution at the end. So x is equal to 5 secant theta, and dx will be equals to 5. What is the derivative of secant?
Secant and 10.
Secant theta tan theta,
Yes.
and d theta. So let's plug the value and simplify this, because this substitution is actually help us to remove the square root. When you substitute these values and simplify, you'll notice that there will no square root left anymore, just like in the previous question. So here, look at this, x square becomes 5 secant theta minus 5. So it's x square, so it becomes 5 square secant square theta minus 5 square. I'm not writing the 5 square as 25, because 5 square is the same on both terms. It can be take out. just like in the previous question, right? And
Okay.
denominator is 5 secant theta, and in the place of dx we write 5 secant theta tan theta. Okay, and d theta. So if you notice that 5 secant theta is the same in numerator and denominator, they can be
Mhm.
cancelled out. And here 5 square is the same, so if we take out from the square root, it becomes 5 outside, and inside it left secant square theta minus 1, right? And no denominator left. There is tan theta d theta. Now secant square theta minus 1. This is equals to what function? You have the trigonometric identities. Second trigonometric identity for in the form of secant and tan. We know that 1 plus tan square theta is equal to secant square theta, right? And from
Yes.
this, if you want to find secant square theta minus 1, so take 1 on the other side, it becomes secant square theta minus 1, which is equals to tan square theta, right? So this term would become 5, and secant square theta minus 1 is actually tan square theta or square root, and here is tan theta d theta. So this tan square and square root is cancel out, and 5 constant take it out from the integral sign, and inside is left only tan theta, and there is one more tan theta, so it combined becomes tan square theta, right? Now you have
Hmm.
this function. So what is the integration of this? How can you find the integration of this? As we know that tan square, there is no integration of tan square, so we convert into the secant square. So it becomes, as you know, tan square is equal to secant square minus 1, right? So it becomes secant
Yes.
square theta minus 1 theta. 1, sorry, not theta, 1, and d theta. So you know that when two functions are subtracting, so we can separate their integration. So 5 is
Hmm.
still outside, secant square theta d theta minus this 5 will also multiply with 1, so 5 outside with 1 d theta. Now you have the integration of secant square theta, which is 5, and secant square theta integration is tan theta minus 5, and 1 integration is just theta plus c. This is the answer, but this is not a final answer. As you know, this is the answer in the form of theta, right? Now you need to find the values of these function and plug it here. Okay, whose function value we need to find? So
Yes.
here you can see it's tan theta and theta. So what we do, we'll find the value of tan theta and theta and plug it here. Okay, so how can
Okay.
you find the tan theta value? I told you that when you need to do resubstitution, you can use the substitution value that we are already plugged in the function. So what value we used while we do the substitution?
Uh, इसमें से हम
What values we use while we do the substitution? In start, we use secant theta, but we need to find the tan theta. So if you have secant theta, can you find tan theta? Because we need to find the tan theta to plug it here. So can you find tan theta by using secant theta?
yes.
Yes, because you know that tan theta and secant theta are connected with the trigonometric identity.
Identity.
So if you have
Yes.
secant or tan, one of them, you can find the other one, right? In substitution, as you know, x is equal to 5 secant theta, right? So what will be secant theta? By take 5 on the other side, it will be x over 5, right? So x over 5 is the secant theta value. Now plug this x over 5 secant theta and find in the trigonometric identity to find the tan theta value. How can you find the tan theta value? As you know, 1 plus tan square theta equal secant square theta, right? So we're going to find tan. Take 1 on the other side, it becomes tan square theta equal secant square theta minus 1, right? So plug the secant square value here, which is x square over 5 square minus 1, and after simplification it becomes x square minus 25 over 25. And here
Okay.
is tan square theta. As we want to find the tan theta value, not square. So take the square root, and after taking the square root, it becomes square and square root cancel out. You left is tan theta, which is equals to x square minus 25 square root, and divided by just 5 left if we remove the square root, right? So we got the tan theta value. Is this the only one which we need to find, plug it in the final answer? Do we have to plug only tan theta here? We also need to plug the theta value here, right?
Yeah.
So tan theta will plug the, in the place of tan theta will plug this function, but what about theta? So if you want to find theta only, so what you do, you to take tan on the other side, okay?
Okay.
But if we take a trigonometric function without angle, then it becomes inverse. So this becomes tan inverse of this function. We'll not write after that. We have to write before of this. This tan will become tan inverse, and inside we'll have this term. So in the place of theta, we'll plug this value, and in the place of tan theta, we'll plug this value. So put the values in equation 1. The final answer that you have, I is equal to 5. Tan theta is square root of x square minus 25 over 5
Yes.
minus 5, and theta is tan inverse x square minus 25 over 5 plus c, right? This is the final answer. If you want to simplify more, this 5 will be cancelled out, but we cannot cancel this 5 with this one. Why? Because this 5 is now inside the angle of tan inverse, okay? So we cannot cancel this 5 with the outside 5. Clear? But we can only cancel with this one. So you left is x square minus 25 minus 5 tan inverse x square minus 25 over 5 plus c. This is the answer. So if you find theta from by this term, you can also find theta from this, because x over 5 is secant theta. So if you take secant on the other side, it can also become secant inverse of x over 5. This is also theta. Now it's your choice to plug theta or this theta. It's up to you. Okay, that doesn't matter whichever the theta you use, because both are the equation, but the only difference is this theta is in the form of tan inverse, and this theta is in the form of secant inverse. So that doesn't matter. So there is another way to write the answer is, in the place of theta I can put secant inverse here. So that this can also become like this, x square minus 25 minus 5 theta. So what theta is? Secant inverse x over 5, right? So minus 5 secant inverse x over 5. So if you write the answer in this form or this form, both are correct. The only difference is, in the above one you plug theta in the form of tan inverse, and the below one is you plug theta in the form of secant inverse. So if you have the question in the form of limit, like we can say this is definite integral. So how would you solve? First of all, look at the same thing, what you will substitute. So if you have the variable start and constant later on, so what you do, you will plug the u is equal to secant theta, right? So the u is, okay, u is equal to a secant theta. What is a here actually? So if we rewrite this equation, this would be look like x square. So if you want to write 3 in the form of square, right, you know that 3 is not a square of any number. So what you do, you can write the square root first, and then you can write the square of any term. Remember, if you have
Yeah.
any number and which is not a square of any square of any number, so what you do, first you write the square root, then you can write the square of the same term, okay? Because after, if you cancel square and square root, it will be same 3 as well, okay, as before. So that's why if you want to make in the form of square, if we can write like this, it means now a becomes square root 3. So put here x is equal to a and a is square root 3 secant theta. Now take the derivative. Dx is equal to square root 3, and secant theta derivative of this, you know that it's secant theta tan theta and d theta. Now plug the dx value and x value. One thing is that you use here, we have write the values of x and dx, but what about the limits? Because these limit is for x, but if you change the x variable into theta variable, so you have to change the limits as well. Okay, so by using this, limit will also be changed. And how the
Yes.
limit will change, look at this. So you have two limit, one is lower limit and one is upper limit. What is the lower limit here? Lower limit is square root
Lower
3,
limit is square
right?
root
So
3. Yep.
if I call lower limit as a, just to understand, okay, you know that lower limit is square root 3 and upper limit is 2. These limits are for x variable. If you change the theta, so when x is square root 3, okay, instead of a and b, let me write x1 and x2. That more understanding for you. Lower limit is x is equal to square root 3 and upper limit is x is equal to 2, right? Now using this will make lower limit again, but a new limit using theta. So as you know, you have x is equal to square root 3 secant theta, right? Now we need to find what is theta. When x is square root 3, then what is theta? So plug x value here, it becomes square root 3 equal square root 3 secant theta. What I did, I just replace x with square root theta, right? And square root theta is cancelled on the both side. You left is 1 is equal to secant theta,
Mm,
right? And take the secant on the other side. So theta will be secant inverse of 1. You can calculate it from the calculator directly, or you should also know that secant is actually the reciprocal of cos. So cos, at what angle cos is 1? Cos give you 1 at 0 degree angle, right? It means secant will also give you 1 at 0 degree angle. It means this theta will be 0 degree. Time to find the upper limit when x is 2. So when x is 2, using the same, x is equal to, you have to use the substitution thing. So x is equal to, as you know, x is equal to square root 3 secant theta. So let's find theta from here. So all you have to do is replace x with 2. So it will be 2 is equal to square root 3 secant theta, and take the square root 3 on the other side. It will be 2 over square root of 3 is equal to secant theta. Okay, so secant theta, and take the secant theta on the other side. You can also find it through the calculator, that what is secant inverse, because secant will go on the other side, it becomes secant inverse 2 over
yes.
square root 3. So what is secant inverse 2 over square root of 3? It means this theta, as the secant give you 2 over square root of 3 at theta is equal to pi by 6. Pi by 6 means 30 degree angle. So in radian it's pi by 6. So lower limit now become 0 and upper limit, but we'll write in radian, so it will be 0, not degree. 0 degree. Okay, so a lower limit is now 0 and upper limit is now pi by 6. So this is very important thing that you have to do while you are substituting. After substitution, you have to change its lower and upper limit as well. How to change
Okay.
lower limit? Use the lower limit, plug into the substitution and get the answer of theta. Use the upper limit and plug into the substitution and get the answer of theta. Okay, now
Okay.
we got the lower and upper limit, so plug it into the question, and other method is the same as we solve. So now it's become 0 to pi by 6, and other thing is same. In the place of x, we plug square root 3 secant theta, so it becomes square root 3 secant theta square in the place of x, minus square root of 3 square divided by x square root of 3 secant theta. And what is dx? Dx is square root of 3 secant theta tan theta dt. Just like in the last question, the same value are cancelled out. Square root 3 cancel with the square root 3, secant cancel with the secant. Okay, now you see square root 3 and square root 3 square both same, so we can take it out from the square root. and it becomes square root of 3 outside with no square, because that square will cancel with the square root. Inside is left with secant square theta minus 1. From both terms, I take the common square root of 3 and take it out, and which will be outside of the integral sign. And denominator, there is no denominator left because it's cancelled out, and here is tan theta. Limit 0 to pi by 6. Okay, so here is square root of 3, and you know that using the trigonometric identity, secant square theta minus 1 is actually equals to tan square theta with the square root, and here is tan theta d theta, and 0 to pi by 6. This tan square and square root is cancelled out. We left is square root of 3, 0 to pi by 6, and 10 becomes tan square. Now you know that we don't have the integration of tan square, so we'll convert into secant square. So it becomes secant square theta minus 1. So I can separate this integral with both. So one with d theta and one is square root of 3 will be both terms, 1 d theta. And now let's find their integration and then plug the limits. Square root of 3, and this becomes integration of secant square is tan theta. Use the limit 0 to pi by 6 minus square root of 3, it's theta, and use the limit from 0 to pi by 6. Now plug the limits, you know, upper limit minus lower limit, right? So this become tan. In the place of theta, you have to plug pi by 6. So tan pi by 6 minus tan 0 and minus square root of 3. It will be pi by 6 minus 0. So first term, what is tan pi by 6? So tan pi by 6 is 1 over square root of 3, and tan 0 is 0. So minus 0, and you have square root 3. And this would be square root of 3 pi by 6, right? So let's just simplify. This square root of 3 and square root of 3 cancel out. The left is only 1. So 1 minus square root 3 pi over 6. If you want to find the answer in decimal, you can find it. Otherwise, that's fine. Okay.